Can everyone hear me all right? All right. So my name is Dustin Whittle. I have a little bit of experience with PHP. I've been working on it for quite a while. You can find out a little bit more about me at dustinwhittle.com or follow me on Twitter for some great insights. In the past, I've worked at SymfonyLive doing consulting and training around Symfony, Silex, PHP, Doctrine, etc. Before that, I brought Symfony to Yahoo to rebuild Yahoo bookmarks, delicious Yahoo answers. And most recently, I work for a company called AppDynamics that does application performance monitoring for PHP. So I have a lot of experience working with PHP and really scalable PHP applications. So the goal of this talk is really to give some insights into how you can do performance testing for your applications. But why does performance matter? When Microsoft found Bing searches that were 2 seconds slower, resulted in a 4.3% drop in revenue per user. When Mozilla shaved 2.2 seconds off their landing page, Firefox downloads increased 15.4%, or 60 million more downloads because the page was slightly faster. And making Barack Obama's website 60% faster increased donation conversions by 14%. So he raised $30 million more because his website was slightly faster. So the reality is that performance does have an impact. My favorite performance statistic is that for every 100 milliseconds that Walmart or Amazon shaves off of their website's end user time, they increase revenue by 1%, which is billions of dollars. So performance directly impacts the bottom line of most businesses. But how fast is fast enough? So 100 milliseconds feels instantaneous. It's like flipping a page in a book. You don't lose your train of thought. But many studies have been done on how often will users abandon a site. And they say that after 3 seconds, a lot of users will abandon. Once they've abandoned your site, they're likely to not return. And of those that aren't willing to return, they're going to say something negative in a review. So this goal really isn't to talk about performance in terms of optimizations, but I get this question a lot, so I thought I'd give you some high-level tips on how to scale Symfony applications. These pretty much apply to any technology stack. So scalability is really about an architecture. It's not about minor code optimizations. It's not about single quotes versus double quotes. It's about really the design of your application, the entire architecture. So if you're not in PHP 5.4 or above, you've had like 5 years, so it's time to upgrade to 2013. My personal preference is PHP, FPM, and Nginx. Obviously, everyone here probably uses Composer already, but use Composer to stay up to date, keep your framework dependencies up to date, et cetera. You can really easily optimize the autoloader with -- optimize, and you can use the APC caching in the autoloader as well. And then with PHP, in order to maintain state across multiple machines, whenever you want to scale beyond a single machine, you need to move your sessions from something besides a file store. So you can use signed cookies or put them in a database and front them with Memcached is a common approach. Anything that is expensive to query and doesn't change very often should be cached. So most result sets for the database and most web service access. So Doctrine has great support for caching, as does the Guzzle HTTP client. Makes it very easy to drop this stuff into any existing project. And then anytime you have blocking work, like you want to post to Facebook, or you want to send an email, or you want to do some expensive operation that the immediate response does not require, you should do that work in the background with tasks and queues. So there's a great library called Resque that makes this dead simple to do in PHP. And then if you're not already using HTTP caching, you should. And you should front it with Varnish, which is extremely performant. Symfony-specific tips: use the Twig PHP extension for minor performance improvement, optimize your front-end assets with aesthetic, and use the Symfony profiler to figure out where your code is slow, and the stopwatch component to do timing. There's a great website to have common production, it's like production checklists for going live with the Symfony2 app. Definitely check it out. And then, as you learned yesterday, SymfonyLive's Insight has launched, and you can plug in your project from GitHub, and you'll get performance recommendations, security recommendations, and code quality recommendations. So it's a very quick way to audit your project. Now, when it comes to performance and performance testing specifically, you really need to have an understanding of your baseline performance. So how does a static hello world HTML page render in Apache? So what's your baseline for Apache? What's your baseline for PHP hello world with no framework? And then what's your baseline for hello world with Symfony, or for your home page, a static content page? So now the real goal of the talk, tools of the trade that I use for performance testing. When you go live for really large applications, you need to do a bit of capacity planning. When your web application is quite small, 1 server, 2 servers, 5 servers, it's quite easy to load test that. But when you have 1,000 servers behind load balancers, how do you drive enough demand to actually load test this? And then how do you do capacity planning to make sure that on the big launch day, you don't fail? So in America, healthcare.gov is a big failure because it doesn't work and nobody can register for their insurance. All of you don't have to worry about that because you have insurance, but all the poor people in America don't. And it's been really frustrating. It's probably the biggest performance incident. And it's really costing President Obama's reputation because this website has failed. And really, it's poor capacity planning. They didn't load test it. They didn't know what to expect in terms of traffic. And the day they went live, everything failed. And now it's been in the news for weeks. So if you've installed Apache, you can use Apache Bench. How many of you, by a show of hands, are familiar with Apache Bench? So this is a very common tool for figuring out the performance of an application. It's very straightforward. So on most applications, you can install it with, on most Debian-based operating systems, you can just do apt-get install Apache 2 utils, and now this command's available. So you can do AB, or Apache Bench, with a concurrency of 10, for a time of 10 seconds against a URL and get very simple metrics on the performance of the application. In this case, I'm load testing my personal site. I get 28 requests per second. I've done nothing in terms of optimization, not the best performance in the world, with an average request time of 35 milliseconds. Apache Bench is installed on most servers that I log into, but my personal preference is Siege. So Siege is also quite powerful, but it's also very similar to Apache Bench. So you can do Siege-C, which is concurrency. How many concurrent HTTP requests do I want to throw at this endpoint? -B is benchmark mode, so that there's no delay between the requests. And then -T is for time. So in this case, I want to throw 10 concurrent HTTP requests for 10 seconds and then get the results from that. So again, very similar to the Apache Bench results, about 28 transactions a second, with the shortest transaction taking 19 milliseconds and the longest taking 54 milliseconds. When you have a large production application, part of the problem is just figuring out which URLs and which user flows do you need to load test. If you have a content-heavy site that's highly cacheable and you're just worried about the request to your homepage, this is a very easy problem to solve. I can just increase the level of concurrency and throw a bunch of traffic just at the homepage. But more often than not, it's much more complicated. I have an e-commerce shop that has searching by categories, product page view, tag view, checkout process, sign-in process, sign-up process, forgot password, et cetera. How do you check the performance of each one of those endpoints? How do you discover all of those URLs? So one of the techniques that I've used in the past is to crawl the entire application as if I were a search engine trying to index the entire site. So I can very easily identify all the unique URLs, and then I can run load tests against that. So I've discovered a great tool called sproxy by the makers of Siege. Basically, all this is a transparent HTTP proxy that will log all the URLs that were made into a file. So this is a bit text-heavy, so bear with me. You can launch sproxy again, sproxy-o, output to a urls.txt. Now the more complicated bit. So I use wget. Wget has a mirroring mode, and wget has a spider mode. So wget with --spider will essentially emulate a search engine. It'll go to your page, discover all the URLs, and recursively crawl every single URL. This is really good if you want to figure out every URL in your application. In this case, I can simply pass it through the HTTP proxy, and I end up with a urls.txt that will give me the complete every URL. And then all I need to do is make that unique, and now I have a list of every unique endpoint in my entire application. Now I can use Siege again. Oh, sorry, wrong order. And benchmark traffic across all the unique URLs. This is very easy. So Siege in verbose mode with a concurrency of 50 users this time for a time of 3 minutes, using this file for the URL, so -f urls.txt. So I can take all the URLs that I've indexed, and now I can load test each one with a delay of 10 seconds in between. And you get this result. That's only so useful. That's good for static pages. That's good for a baseline. It's very easy to do this across static pages and dynamic content, but it's quite simple. And most applications are really not that simple. If you prefer a GUI approach, you want a graphical user interface, there's Apache JMeter. Apache JMeter is quite easy to use. It looks like this. You can simply create a benchmark profile and add which URLs you want to test in a graphical fashion. I'm not a big fan of this, but it's very common, and I thought I would point it out just because it provides a GUI interface for all the stuff that I tend to do in code. So how many of you know Python by a show of hands? All of you? All right, perfect. So I use this library called Multi-Mechanize. Multi-Mechanize is essentially a performance testing framework written in Python, but it's quite flexible. So it's very easy to install. Just like there's Composer for PHP, there's pip for Python. So I can simply run pip install multi-mechanize, and I can use the commands right away. So you can bootstrap a new project very easily with multimech-newproject demo, and it'll give you some boilerplate code. But what that looks like in its simplest form is I want to have a transaction. In this case, the transaction is simply to go to the home page and fetch that. And this transaction will run in a loop at whatever level of concurrency you want. But what about when you want to do something more complex, like test the performance of an application flow? Like I want to register a user, sign in, add a product to the cart, check out, go through the checkout process, and see an order review. You can actually use this to do scripting quite easily with very granular timing API. So in this case, you can import multi-mechanize, import timing API, and then you can use the Mechanize browser. So the Mechanize browser allows you to essentially use what is an emulated browser on the server side. In this case, I can add as many flows as I want. And here, I'm simply using the Multi-Mechanize browser and opening my home page again. But I could add as many of these as I want. So if I want to test, it has full support for cookies and sessions, so it can maintain state between requests. It also has, what you don't see, is a setup and teardown method. So if I want to destroy the session in between, I can also do that. This is really good for, again, testing user flows. So if you use something like Varnish or Varnish Replay, it's really easy to figure out what are the most common flows, or you can do funnel analysis if you use something like Google Analytics. You can see what are the most common flows in my application, and then load test against that. Because the load test is only as good as your data is. Or another way to say it is you need to test the flows that users actually go through. If all you ever do is test your highly cacheable homepage, when people start to sign in at 10,000 concurrent users, the sign-in endpoint is going to start failing. So you need to really test the complete application, not just some pages. This is a simple configuration for multi-mechanize, where it says that I want to run this for 10 seconds. I want to ramp up over 5 seconds, and I want the results time to be every millisecond, or in this case, 1. In order to run this, I can simply run multimech-run demo. And what it'll generate is a very nice graphical report of response time over the time of the benchmark. So you can also correlate to actually the raw data points, which are the response times for each individual request. So from this, you can get a high level of each different flow. And if I go back a bit, you can actually track each one of these flows independently with custom timers. So here, all I'm doing is creating a timestamp before, making the request, recording the latency of that request just by subtracting the time, and then adding it to the custom timers. But I could do this as many times as I want and run this in a loop with high levels of concurrency. And then for each one of those endpoints and each one of those custom timers, you'll get a graph like this. So how long does it take for a user to sign up, add something to the cart, and then check out? Or something simpler, which is what this shows, is how long does it take to just fetch the home page? But what happens when you have more than one app server? How many of you run complex applications? More than 5 app servers, by show of hands. Everyone else, less than 5, I presume, so fairly straightforward. Okay, so if you deal with high levels of concurrency, you need to change up your approach, because you can't just use a single server to generate load. How many of you live in the cloud? Well, that's depressing. Thought there would be way more. Cloud's all the rage, in case you haven't heard. But the reality is you really need to change your approach when you have many instances that respond based on load. So the benefit of using cloud services is that costs scale linearly with demand. So I only need to add as many app servers to support the current production traffic. And you can scale this up and down. But you really need to get a sense of how far can you scale it up before you max out your database backend or external web services that you rely on. In order to generate that level of load, you generally need to use more than one app server. So one of my favorite projects in the world, just because of the epic name, is Bees with Machine Guns. Say it with me, Bees with Machine Guns. Oh, sad. Look at that logo. Come on, who doesn't love this? All right, so Bees with Machine Guns is a utility for arming mini bees to attack targets, where arming means creating Amazon EC2 instances to load test web applications. This is the only open source project that I know that comes with a legal warning that says if you use this, you risk a felony, because this is essentially a distributed, it's a DDoS attack, right? It's a distributed denial of service attack. Very easy to get started. You can take down most of the websites on the internet with this in just a few minutes. So pip install Bees with Machine Guns. Again, it's a Python library. It's very scriptable. It's very easy to use. So the only thing that it really requires is EC2 credentials. So since like 2 people here are using the cloud, Amazon has this service where they provide machines in the cloud, which is like way up there. Anyways, you can sign up for AWS for free, aws.amazon.com/free, and get some credentials and start using this today. But essentially, all you need is a key and a secret, and then you can pick your region. I live in California, so I use US West 2, but they have regions all around the world. Once you've configured this, essentially what you need to do is spin up multiple machines. So in this case, I'm limiting this to 2. So the people that developed this is the Chicago Tribune. And they have a great sense of humor if you see the results in just a second. So here we're going to say bees up, which bees is a command line for Bees with Machine Guns. And then we're just specifying the number of servers. In this case, I just want to spin up 2 EC2 instances with this image. So this image just has some load testing tools available by default. Like it has Apache Bench and Siege built in, so I don't have to do any commands to set it up. And then I'm specifying the user that I want to SSH in as with the SSH key. So what you don't see in these slides are all the notes, but these slides are available on Speaker Deck with very elaborate notes at the end. So if you want to understand how I got through all these flows, feel free to follow up online. When you call bees up, you get this hilarious output. So I'm connecting to the hive. I'm attempting to call up 2 bees. I'm waiting for bees to load their machine guns, spin up EC2 instances, and then it'll report back when the bees are ready for attack. So the swarm has assembled 2 bees. You can ask them to report their status, which will just tell you which instances are currently in the pool. And then I can have them attack a URL. So when I want to attack, again, my personal homepage, I can do bees attack with the number of requests I want to send or just the level of concurrency in a time. In this case, I want to say I want to send 1,000 concurrent requests for 100,000 total requests to this URL. This is a very easy way to generate 1,000. So with 2 machines, I could easily generate 50,000 concurrent requests or 20,000 very easily. So you can scale it just depending on which level of concurrency you need to test. So again, you get this great output, which is reading 2 bees from the roster, connecting to the hive. I'm assembling the bees. Each of the 2 bees will fire 50,000 rounds, 125 at a time, to the URL. And then essentially what this is doing behind the scenes is in parallel, SSHing into all the machines and then running siege against this URL. So depending on how the results go, the bees are going to join the swarm. They're firing their machine guns, bang, bang. And then when they're out of ammo or it's made all the requests, the offensive is complete. So here you get some statistics. Whoops. You get some basic statistics like how many requests per second were achieved and the average time per request. In this case, the target crushed the bee offensive, so my server can easily handle this load. But if not, you'll be able to see the performance problems. So this is a really good way to generate load and throw it at your application, but you need to be able to monitor your application to figure out what's actually going on when things start to fail. Again, there's bees down. Just like bees up spins up EC2 instances, bees down will turn them off. Since you pay for EC2 instances by the hour, you don't want to squander resources, even if it's free. But How many of you know how fast your site is in production? By a show of hands. Less than 10% of the room? The rest of you have no idea. It's just when things start to fail and user complains. How many of you find out when something's wrong by a user complaining, by a show of hands? It's got to be more than that. Some of you are lying. Let's be real. All right. So the company I work for is called AppDynamics. What we do is application performance monitoring for PHP, Java, .NET, and Node.js. But essentially, you can install our agent into your application, and you get an application flow map. This is extremely useful when you're doing performance testing. So the service is free to try, so any one of you can sign up for free right now and load test your application and understand the real performance of this. You'll understand which database backends you're talking to, which web services you're talking to, any caches you're using, any queues you're using. But more importantly, I'm not sure how legible this is on the screen, you can see what the performance looks like for every single bundle and controller action. So you get a breakdown of performance in production with real load for your entire application. When performance starts to deviate, when you're actually having problems, you can get code level visibility into why you're having those problems. As well as you get the end user experience. So not only the server side, but the client side as well. More importantly, you can track any metric and compare releases over time. I imagine everyone in the room are coders and are happy to do all this stuff in code, but some of us are lazy. I'm very lazy. I prefer just to click on stuff when I can, and so there's a lot of good services that are available in the cloud. So one of the ones I'm a big fan of is blitz.io. So blitz.io is a cloud testing service where you can pass in a URL or a series of URLs and toggle a dial to say, I want to send 10,000 concurrent requests or 50,000 concurrent requests. The only thing you really need to do is prove that you own that domain, and then you can get started. It's free to sign up, and it's free to send, I think, up to 100 concurrent requests, and then you pay for it over that. If you want more, blitz.io is really good for simple testing, so it's the equivalent of a siege in the cloud. But if you need something much more than that, there's Apache. So Apache does load testing. You can simulate user scenarios. You can simulate real browsers, real end users, not just API requests. And it works well for mobile devices as well as native mobile applications, as well as global access. So one of the things I use beeswithmachineguns for is I spin up an instance in California. That's fine, but it's hard to test the performance in Germany if I'm only using something that's in region. A data center that's in that region. So with Apache, one of the benefits is that I can spin up traffic globally. And they have like 50 data centers around the world. So it's very easy to get a global perspective of what your application performance looks like. There's BlazeMeter as well, which I'm a fan of. You can actually use it really easily, but it's straightforward. The best thing about this is it's compatible with JMeter. It's basically a cloud-based version of JMeter. And you can throw in a JMeter profile and run it against high levels of concurrency. And then SOSTA. One of the goals of this talk is really to convince you that you need to integrate automated performance testing into your continuous integration cycle. How many of you do unit and functional testing today? All of your hands should be up. Seriously, all of your hands should be up. That's just... So everybody takes functionality and application testing serious, but very few people take performance testing serious. And nobody cares until something's broken in production and everything's down. The reality is, the more you monitor, the more you can be proactive about it. You shouldn't wait till you're at the worst case scenario with everything being down. You should really be proactive. So you need to have production monitoring. You need to do capacity planning and load testing. And the best way to do that is to integrate some of these tools as part of your Jenkins process or as part of your Travis CI process. It's pretty straightforward and easy to do that way. Every time you do a commit, you can understand the performance implications of those code changes. But it's not just code changes. You need to understand the performance implication of every deployment and every package upgrade. A lot of performance problems come from upgrading your MySQL database or changing your PHP version or upgrading some extension. So being able to see it from a holistic perspective, the application performance is crucial. So again, monitor production performance. It's one thing to use Symfony. Everyone loves the Symfony profiler. That's one of the things that made me fall in love with Symfony early on was the web debug toolbar. It's only gotten better. Now there's the stopwatch component, so it's extremely easy to implement lines of code. So it's crucial to monitor performance, not only in development, not only for profiling, but also for production and your end users. I think for a lot of engineers, there's a focus only on the server side, but the reality is in modern web applications, you spend more time on the client side than you do on the server side. The 100 milliseconds you spend waiting for the server side to respond is nothing considering the 2 seconds you're going to wait for the DOM to render and all the assets to be downloaded. You need to not only do production monitoring for server side, but also for the client side, and there's a variety of tools to use in order to do that. So I think I went a bit fast on this talk, but I'm happy to take questions, or if you'd like, I have a bit more content on client-side performance testing. Any questions so far? Don't be shy. Could you repeat that?
Is there a tool that simulates requests from a web server log file, for example, from Nginx or Apache?
Yeah,
in
so
the
what
same
you can,
order?
Yeah, so one of the things that you can do is actually replay the log. So in the same way I scraped the URLs out originally with Siege, you can use Siege to discover all of the URLs by crawling your site. But another approach to that is actually to replay your production traffic. So Varnish Cache has something called Varnish Replay, which will record the most common user flows and allow you to replay them. That's one scenario. Or you can simply parse out the most common patterns from your Nginx access logs. I don't know any tools off the top of my head that will just take an Nginx log file and give you the most common URLs, but it's fairly easy to grep them out and just do a filter on unique count. Any other questions? All right, I think I have a few minutes left, so I'm going to dive into a little bit more on the client side because I think this is an important topic. As a bunch of PHP engineers, how many of you actually work on JavaScript? Right. Most everyone works with JavaScript and CSS and has to deal with some level of HTML. Yahoo once released YSlow, which I think a lot of people are familiar with. The second generation of that is something released by Google called Google PageSpeed. Google PageSpeed provides Google PageSpeed Insights, which is advice on how to optimize the client side of your application. They offer this in a few different ways. One, as a website where you can simply throw in a URL and get performance recommendations. Simple recommendations like minify JavaScript. This is very easy to accomplish with Ascetic, both for CSS, JavaScript, as well as leverage browser caching, so HTTP caching headers. It'll tell you where you're being efficient and where you're not. They offer this as an extension to Chrome. But my favorite bit is they offer this as a web service. So I can just pass in a URL and integrate this as part of my continuous integration flow. So if you go to developer.google.com, it's really easy to sign up for a key. And then I can get a JSON response by simply calling this URL. So Google API's PageSpeed Online, run PageSpeed with this URL and this key. What this will give you is this advice as a JSON blob. But more importantly, it'll give you a score. So what you can see is the delta in between code changes. And that's what you should really track in between requests, is what is the difference from the most recent code. More and more people are using Ember, Backbone, Angular, et cetera, where a lot of the heavy lifting is actually done on the browser side. So that logic, the web page used to be glued together on the server side and then passed to the user. More and more, all that heavy lifting is done on the client side, and all they're using for the server side is the data. So let me access this REST API and then glue together all of the views in the browser. The more you do that, the more you move, which I think is the most modern approach to building production web applications these days, the more you actually need to track the performance on the client side, because there's a big difference over time. So I use this tool called wbench. Wbench allows you to get a breakdown of timings using the W3C navigation timing API. This is a Ruby tool, so just like pip in Python or Composer in PHP, there's Ruby gems. So it's very easy to install on most machines with just gem installed wbench. And then you can run wbench against a URL and get a breakdown of how much time was spent. How much time was spent waiting for the server to respond, how much time was spent waiting for DNS lookups, how much time was spent waiting for the DOM to load, and then for the DOM to become interactive, right? So this is something, again, that you can integrate as part of your continuous integration flow. I think everyone here uses the Symfony command line, Symfony task. Just like Symfony task, there's Grunt, which is a JavaScript automation tool. Just like Composer, there's Bower, so you can manage your JavaScript dependencies. Twitter released Bower a while ago. It's basically Composer for JavaScript. There's Grunt, which is the equivalent of Symfony2 task for front end, and Yeoman for bootstrapping projects. It's the equivalent of like Composer create project with a set of sane defaults. I'd recommend all of these tools. But the reason I mention this is so that you can use Grunt and Grunt PageSpeed to easily automate all of your performance testing on both the server side as well as the client side. And then if you just want simple videos of your website, I'm a huge fan of this service. It's one of the best free services I've never paid for. So you can go to webpagetest.org, simply throw in a URL, and pick a browser and a location, and it'll tell you what the performance was like from that location. But it's the equivalent of running Chrome in this location. So you get a waterfall for the timeline, and then you get, again, all the navigation timing APIs. This is extremely good to be able to tell the performance from many browsers. The hardest part of doing all this is doing it across many different browsers and operating systems. So unless you have a bunch of test machines yourself, it's really hard to spin this up. This is a great service where you can simply throw in a URL and say, I want to try IE6 from Frankfurt. And then one of the best parts is you can actually get a screenshot and a video. So if you want to do it for quality assurance, it's very easy to get a video of the page rendering, and then you can compare that over time, or simply grab a screenshot. Again, it's free and it's not rate limited, or at least I haven't hit a rate limit yet, so knock yourselves out. And that's all I have. Any other questions? Let's not hold back. I've answered all of your questions for the day. All right, well, thank you very much, and enjoy the rest of SymfonyLive.